Hey everyone, I gonna discuss about hypothesis test for one population mean when sigma is unknown. Let's get started. This slide we are going to see p-values for a t-test. If we let t0 our observed values of the test statistic t, then we can determine the p values. Figure A shows this is two-tailed. Figure B shows that this is for left-tailed. Third figure shows that this is for right-tailed. In figure A, the arrow sign indicates the area. The area under T curve lies outside of the interval. The interval from negative modulus T0 to positive modulus T0. From second figure, the area lies left side of T0. From figure C, we notice that the area lies right side of T0. Now we are going to see example. This example is how to estimate the p-value. This is left-tailed t-test. Here we consider sample size 12 and test statistic t equals negative 1.938. Here we are going to see the figure A. In here we see df equals 11. And we need to calculate how df equals 11. So we know that df equals n minus 1. Here our sample size or n equals 12. So we can easily calculate 12 minus 1, that is 11. And from figure A we see that the area lies left of negative 1.938, and we know that the t curve is symmetry about 0. So the area to the left of negative 1.938 equals the area to the right of 1.938, which can be estimated by the table in our textbook. We need two t values. One is t 0.05 equals 1.796, and we need another values, that is t 0.025 equals 2.201. And from figure B we can see that the area under T curve lies right side of 1.938 between 0.025 and 0.05. Now on next slide we're gonna see another example. This example is for two-tailed t-test. Here we consider sample size is 25, and we also consider test statistic t equals negative 0.895. And from figure A we see that df equals 24. This is the same calculation as previous example. From figure A, the area lies left side of negative 0.895 and right side of 0.895. And we know that T curve is symmetric about 0. The areas to the left of negative 0.895 and to the right of 0.895 are equal. And we need one t value, that is t 0.10 equals 1.318, the smallest value. So therefore the area under T curve that lies right of 0.895, therefore is greater than 0.10, which we can see from figure B. Now we are going to see the procedure of one mean t-test. To perform one mean t-test, we need some assumptions. First assumption, simple random sample. Second assumption, normal population or large sample. Third assumption, sigma is unknown. Now we are going to discuss the step of one mean t-test. Now we are going to figure out the null hypothesis and the alternate hypothesis. In here, null hypothesis is denoted as 0 when mu equals mu naught. The alternate hypothesis, when mu does not equal mu naught, this is called two-tailed test. Another one is mu less than mu naught, this is called left-tailed test. Another one is mu greater than mu 0 or mu naught, this is called right-tailed. Now we are going to move step 2. Now we need to give the decision over the significance level. Here alpha is our significance level. Now we are going to see step 3. We need to compute the value of the test statistic by this formula which is shown on screen. Finally, denote the value t0. Now we are going to move critical value approach. Here is step 4. Step 4 provides the critical values are plus minus t alpha over 2. This is for two-tailed. Another critical values we can consider negative t alpha. This is goes for left-tailed, and another critical value is t alpha. This is for right-tailed. Now we can say that df equals n minus 1. I already discussed this formula in previous slide, and we need to find critical values. So we can use our textbook, because in our textbook there is a table so that we can easily find the critical values. The first figure is two-tailed and second figure is left-tailed, third figure for right-tailed. Now we should go for step 5. Step 5 suggests us the rejection of null hypothesis and not rejection of null hypothesis. If the value of our test statistic falls in the region of rejection, then we can reject H0. Otherwise, it is not needed to reject H0. Now on next slide, we are going to see p-value approach, and here is step 4. Step 4 provides us the t statistic has df equals n minus 1, and we also need to compute the p-value. So we can use our textbook, because there is a table, we can easily find the p-value. Here is 3 figures for p-values. First one is two-tailed, second one is left-tailed, third one is right-tailed. Step 5. Step 5 suggests us if p less than or equal alpha, then we can reject H0, otherwise we do not reject H0. Now we can move step 6. Step 6 tells interpret the results of the both hypothesis test, that is for critical value approach or p-value approach. Now one thing it is important to remember, that is the hypothesis test is exact for normal population, and it is also approximately correct for large samples for non-normal populations. Now we are going to see example of one mean t-test. This example is related acid rain or lake acidity. Here is the table of the next slide shows the pH levels of the 15 lakes. Here our sample size is 15, so we can say that n equals to 15. And significance level is 5%, so we can say that alpha equals 0.05. And our mu naught is 6 because a lake is classified as non-acidic if it has a pH greater than 6. In here we need to compute, do the data provide sufficient evidence to conclude that on average high mountain lakes in the southern Alps are non-acidic. So here we can see a table of pH level for 15 lakes. From this table we can calculate X bar, we can calculate S, and in our example we already have mu 0 equals to 6, alpha equals to 0.05, n equals to 15. So by using this data and following the steps, we can conclude that, we can compute that the data provided sufficient evidence on average high mountains lakes in the southern Alps are non-acidic. Now we are going to see another example. This example is about 20 people. Here is a table. This table is number of hours of television watched per day. Here is a significance level 10%, so we can say that alpha equals 0.10. And here is X bar equals 4.760 hours and S equals 2.297 hours. And we can also have mu 0 or mu naught equals 4.55. So by using this information and following the step, we can also compute that at 10% significance level, the data do not provide sufficient evidence to conclude that the amount of television watched per day last year by the average person differed from that in 2005. Here is for today. Thank you everyone.